This class is all about the laws of chemical combinations. Oh yes. So in the laws of chemical combination, the quick question is, what is expected of us to know as far as Jamb syllabus is concerned, as far as Waec syllabus is concerned? Let's look at it together, back to back. Yeah, let's go. First thing, we're going to start with our lesson 1, right? And in lesson 1, I'm going to open up your eyes to a lot of beautiful things. First, what is the introduction to the laws of chemical combination? I'm sure you know my guy, right? Oh yes. Of course, he did something very lovely, and that's John Dalton. So John Dalton gave his atomic theory, and his atomic theory provided a satisfactory foundational basis for the laws of chemical combination by mass. In other words, which person's theory, right, opened us up to everything about the laws of chemical combination? That was the atomic theory of what? John Dalton. And of course, his postulate gave rise to 4 gravimetric laws. Anytime you hear the word gravimetric, first and foremost, what is gravimetric analysis? It's under your quantitative analysis. That has to do with your weight or your mass measurement. That's gravimetric analysis. So the postulate of John Dalton was what gave us insights into 4 gravimetric laws. Listen carefully. And these gravimetric laws, or these 4 laws, are the laws that govern chemical combination. And how many are they? There are just 4 of them. Now, which person's postulate or atomic theory talk about the whole of them? That's John Dalton's atomic theory. Now, what are the 4 laws of chemical combination? Number 1 is what we call the law of conservation of mass. What is it called? The law of conservation of mass, or the law of conservation of matter. That's number 1. Number 2 is called the law of definite proportion, or the law of constant composition. You see, a lot of times people try to swap the 2 of them. Listen carefully. C and C go together. Constant composition, CC. So you see that you call it definite proportion, or you call it the law of what? Constant composition. The first is the law of conservation of what? Mass, or the law of conservation of matter. It is not energy. It is not energy. This is one of the areas I have problem with students. It is not the law of conservation of energy that is under the law of your chemical combination. No, what we have is the law of conservation of mass, or the law of conservation of what? Matter, not energy. Number 2 is the law of definite proportion, or the law of constant composition. And then number 3 is what we call the law of multiple proportion. What is it called? The law of multiple proportion. And then number 4 is the one we call the law of reciprocal proportion. And because the word reciprocal also means inverse, it is also called the law of inverse proportion. Either you call it reciprocal proportion or the law of inverse proportion. But please, this 4th law is not commonly used. No. In other words, Jamb don't stress you with questions there. Why don't stress you with any question there? Give me the 4 laws of chemical combination. Number 1 is called the law of conservation of mass, or the law of conservation of matter. Number 2 is called the law of definite proportion, or constant composition. Number 3 is called the law of multiple proportion. And then number 4 is called the law of reciprocal proportion, or the law of inverse proportion. Does it make sense? If you know all of them very quickly, we're going to start with the first. And that first is the what? The law of conservation of mass, or the law of conservation of what? Matter. And I told you it is not the law of conservation of what? Energy, right? They look similar, but they are not actually the same. Now, first and foremost, in the law of conservation of matter, or the law of conservation of mass, the first thing we have to know is the origin. Yes. Who was the scientist that opened our eye to the law of conservation of mass after John Dalton has brought his own theory? Of course, the guy is the one we call Lavoisier. Who? Lavoisier. Your Anton Lavoisier. He was the first person that suggested or formulated the law of conservation of matter, or the law of conservation of mass, in what year? 1774. That's the late 18th century, 1774. Now, who was this scientist that talked about the law of conservation of mass, or the law of conservation of matter? His name is Lavoisier. What year? 1774. And of course, this is my G now. Lavoisier, I am man. Look at Waec question. Show you the villa now. As I'm telling you, I'm giving you their questions back to back. every singular question as far as WAEC is concerned or JAMB is concerned, as far as your exams are concerned, I'm going to be giving you all their questions back to back. WAEC 2022, question 50. And look at the beautiful question WAEC asked. WAEC said, which of the following scientists formulated the law of conservation of mass? You feel me? Option A, we're giving A. Lavoisier, that is Anton Lavoisier. Option B is J. Dalton, that's John Dalton. Option C is R. Boyle, that's Robert Boyle, the guy that gave Boyle's law. And then option D is J. Proust, that's Joseph Proust. Listen carefully. Which of the following scientists postulated the law of conservation of mass? I don't expect you to fail this because I just told you. It was formulated by who? Your Lavoisier, making option A the correct answer to this. Now listen carefully. I told you that the guy's name is who? Anton Lavoisier. This is the spelling for the Anton. Anton Lavoisier is credited with formulating the law of conservation of mass in what year? 1774. If you get this very quickly with me, that Lavoisier was the one who talked about the law of conservation of mass. The quick question is, what is the definition for the law of conservation of mass or the law of conservation of what? Matter. What is the definition? If I have to define it, what do we even say? Are you with me? Well, let's go together. If they ask you, they will always ask, now, the law of conservation of mass or the law of conservation of matter states that during the course of a chemical reaction, matter is neither created nor destroyed. I wish it were energy now. You know, here will no longer be matter, here will be what? Energy. That's why I said it is called the law of conservation of matter or the law of conservation of mass, not energy. During the course of a chemical reaction, when chemical reaction is occurring, matter is neither created nor destroyed. No, but can be converted from one form to what? Another. Want to go, what is the law of conservation of mass or the law of conservation of matter? It states that during the course, right, or the process of a chemical reaction, matter is neither created. You can't create matter and you can't destroy matter, but can only be converted from one form to another. For the last time, what is the definition for the law of conservation of mass or matter? It states that during the course of a chemical reaction, matter is neither created nor destroyed, right? But can be converted from one form to what? Another. And I'd like you to note this very quickly. Hence, in any chemical reaction, what it signifies that the total mass, total what? Mass of the reactants equals the total mass of the products. In other words, any chemical reaction at all that you are given, right? The total mass of the reactant is equal to the total mass of the what? Product, according to the law of conservation of mass or the law of conservation of what? Matter. Okay, let me give you a little breakdown. You know your neutralization reaction, right? The reaction between an acid and a base to produce water. Let me say acid like HCl, right? Reacting with a base, sodium hydroxide. What will it give us? Salt, NaCl, and what? Water, H2O. This is your neutralization reaction. This guy here is called the reactants, and this guy here is called the products, right? Now listen. Now, according to the law of conservation of mass, what does it state? In any chemical reaction, the total mass of the reactants, so your HCl and your NaOH, their mass put together, if it is equal to the mass of the product, the salt and the water put together, if it's equal to the mass of the product, what has it obeyed? It has obeyed the law of conservation of mass. Want to go? What is the definition for the law of conservation of mass or matter? During the course of a chemical reaction, matter is neither created nor destroyed. But what? Can be converted from one form to what? Another. If you get this very quickly with me, you look at WAEC question, WAEC 1994 question 15. WAEC adds this intelligent question, and the question saying any chemical reaction, right? The total mass of the products is always equal to that of the reactant. This statement, or this is a statement of the law of what? So you are feeling it now. Option A say it is the law of definite proportion. Option B say it is the law of conservation of matter. Option C say it is the law of multiple proportions. Option D say it is the law of reciprocal proportions. What is the correct answer? Of course, In any chemical reaction, when you do your total mass of the reactant is equal to total mass of the product, what does it obey? It obey the law of conservation of matter or the law of conservation of mass, making option B correct answer. Hold on a bit. The complete series of classes, right, as far as your syllabus is concerned regarding your Jamb and Waec, everything has been covered in details for you in the LearnLift app. And guess what? The sweet part is that you have access to your CBT, right? You have access to your video lessons, you have access to your notes, you have access to your past questions. Everything from the beginning to the end is directly in the LearnLift app for you. So all you have to do is just mark down to Play Store or App Store and download the LearnLift app where you follow all your classes from the beginning to the end. A quick one before we move. Let's get back to class. Enjoy. Why? Because I taught you something very, very lovely, that the law of conservation of matter is also known as the law of conservation of what? Mass, right? And it states that in any chemical reaction, total mass of the reactant equal to the mass of the what? Product. Does it make sense? Right? Told you who formulated the law. Lavoisier formulated the law, Anton Lavoisier, and I've given you the definition. The next thing that they want you to do very, very quickly is the experimental verification of the law of conservation of mass or matter. How do I verify it? Right? Now listen carefully. As a Waec student, you must know this. As a Jamb student, if you don't know this, you are going to fail some couple of exam questions in the hall. Now listen carefully. What is the experimental verification to the law of conservation of mass or the law of conservation of what? Matter? Very simple. First and foremost, there are 5 steps. How many steps? 5. So I'm going to be giving all of them to you one after the other. In fact, you can run the practical yourself. Are you with me? Now, look at step 1. Measure 50 cm cube, that means volume, of what? Bench solution of dilute HCl and transfer it into a plain conical flask. In other words, what is the first thing I need? First thing is that I need my conical what? Flask. And this is your conical flask. And we are to measure 50 cm cube of your what? Bench solution. When you hear bench solution, what is bench solution? Bench solution is an experimental solution, right? All those reagents that you have in the laboratory that used to carry out experiments, all of them are called bench solution because they are for experiment, they are for experimental purposes. That's why we call them bench solution. Measure 50 cm cube, right, of bench solution of dilute HCl. So measure HCl, 50 cm cube, and transfer it into a clean conical flask. So I'll pour it into the conical flask, and this is my what? Dilute HCl. I am Sir Peter. Talk to me. Follow me. Marshall. What is step 2 very quickly? You see, we have measured the bench solution, right? That's HCl. Step 2 is I've filled a clean test tube. So I need a test tube with a bench solution. That's experimental solution of what? Silver trioxonitrate 5. And the formula for silver trioxonitrate 5 is AgNO3. This is your silver trioxonitrate 5. I'll measure silver trioxonitrate 5 half. Fill test tube. Carry your test tube. Pour it half of it, right? And you don't fill the test tube to the brim. Fill it to half. You get it now. And then the next thing is lower it carefully using a thread. So first, I need a test tube that will contain my silver trioxonitrate 5. Number 2, I need a thread, right? And lower it into this conical flask. This conical flask that we have here, lower it into it. Then cork. So I need my number 3. I need a cork. Cork the conical flask. Do not mix the solution yet. We are told not to mix it. So I need my test tube that is filled with my silver trioxonitrate 5, attached my thread to it, and lower it into the what? Conical flask like this. Say you are feeling it and you are following me. You can see your test tube, and that test tube contains your what? Your silver trioxonitrate 5, AgNO3. They say do not mix the solutions yet. Have I mixed it? No. I only use my thread or rope to tie it outside. I told you we need 3 things there. Number 1 is your test tube. Number 2 is your thread. Number 3 is your cork. And then number 3, they say then cork the conical flask. The conical flask and to cork it, right? And then this is my what? Cork there. Oh, are you with me? Very simple, easy and direct. You see, this period that you are studying now, success is your portion. We just they follow me as we are going together. Are you understanding it now? Now, step 3, very, very quickly. What do we do in step 3? We are told not to mix it yet. In step 3, weigh the entire setup on a chemical balance. So, carry your chemical balance and weigh the entire setup and record the mass. That mass, you are the one that know whatever the mass is. I'm taking it as my X gram. That's what I'm going to take it as. Right? This entire setup, this entire experimental setup, weigh it. After weighing it, we are going to step 4. In step 4, what happened there? Mix the 2 solutions. What are the 2 solutions? A dilute HCl that is inside the conical flask and the silver trioxonitrate 5 that is inside the test tube. Mix the 2 solutions together. How do we do that? By mixing the 2 solutions. This thread, lower it. You can see that this gap lowered inside it, right? And what happens? There is an immediate formation of a white precipitate. Now, why is there an immediate formation of white precipitate? That's the first thing first that should be coming into your mind, but listen carefully. Please wait for a while. As you have lowered it in, wait for a while. Even if the white precipitate is forming, allow it to form totally, right? Now, don't forget that there are 2 things there, dilute HCl and my silver trioxonitrate 5. If the 2 of them mix, what will happen? A white precipitate will form, right? Yes. What is the equation for the reaction? Now, what happens is this very quickly. My silver trioxonitrate 5, aqueous, mixes with my HCl, aqueous, dilute hydrochloric acid. What is it forming? It's forming my silver chloride, solid. This silver chloride is what is forming the white precipitate, silver chloride. And then that's your trioxonitrate 5 acid is given at the end of the day. Follow me. In step 4, when you mix the 2 solutions, what we form? A white precipitate is going to form. Why is the white precipitate being formed? Because of the formation of my silver chloride. And that silver chloride is solid. And that's the white precipitate, which is the AgCl, is the word solid silver chloride that is being formed. And then it rushes into step 5. And what is step 5 there? Step 5 is reweigh the entire setup. The same way you have done before, reweigh and record the mass, but this time take the mass as what? Y gram. You know, the first one we took it as X gram, the next one now we're taking it as what? Y gram. After the reactants are mixed together and they have gotten the product, I am now weighing it. Now please listen carefully. What is the expected experimental results? In A here, what have happened? A, you can see that no mixing have occurred yet, right? And then in B, I have lowered the thread and then I've mixed 2 of them together. What is the expected experimental result? Now, what I expect is this very, very quickly. Total mass before mixing, that means the mass of the reactant, that means the mass of the entire setup in A. And after mixing, that is the mass of the product, which is what? B, will be equal. If the 2 of them are equal, that means they have just obeyed the law of conservation of what? Matter, or the law of conservation of mass. If the 2 of them are not equal, that means they did not obey. Are you understanding it now? And of course, what is the law of conservation of mass, or the law of conservation of matter from the definition? We said that during the course of a chemical reaction, matter is neither created. We are not creating a new matter. We are not destroying any matter. It can only be converted from one form to another. How do we know that it has been converted from one form to another? Because your dilute HCl reacted with your silver trioxonitrate 5 to go and form my what? Silver chloride. It is converted from one form into what? Another. The white precipitated silver chloride and my HNO3, which is your trioxonitrate 5 acid at the end of the day, right? And don't forget this, that I also established that S, in any chemical reaction, the total mass of the reactants always equal to the total mass of the what? Products in any chemical reaction. Please, if you get that, there are 5 powerful things that you always ask exam questions from. Yes, how many? 5. 5 powerful things that we have to note as far as this class is concerned. Number 1 thing there is that any precipitation reaction, carry your pen, be writing with me. Any precipitation reaction or neutralization reaction can be used to explain the law of conservation of mass or the law of conservation of matter. 5 things to note about the law of conservation of mass or the law of conservation of matter. Please, what type of reaction can we use? Any precipitation reaction or neutralization reaction can be used. That's number 1. Number 2 thing that you must hold tight is this: reactions in which a solid or a gas is a reactant. Now, follow me very squarely. Reactant, it cannot be used. So if you have any reaction that the reactant, we are not focusing on the product now, we're talking about the reactant. If the reactant is a solid or a gas, it can never be used to demonstrate the law of conservation of mass or the law of conservation of matter. Why? Because of 2 things. Number 1, it is difficult to weigh your gaseous reactants. Imagine one of the reactants is gases. Can you weigh the reactant that is a gas? No, it is difficult to weigh it. So we cannot use gas as a reactant. And another thing is this: why reactions that involve solids, you can't use them because their reactions are relatively slow. You cannot use a gas and a solid reactant because anything that involves solid, their reactions are always slow. So we don't have the leverage of time to come and waste. Please look at the reaction we're giving. Your silver triazonitrate 5 aqueous. Is that not what we used? Yes. This guy, HCl dilute HCl, aqueous. If you watch, the 2 reactants are aqueous. So we are good to go. If it is liquid, we are also good to go. But we cannot use whatever that is solid or what gas as reactants. You can't weigh gaseous reactants. And your solids, their reactions are very, very slow. If you understand this very quickly, please look at Jamb 1978 question 44. Jamb asks, you are familiar with this diagram already. I don't need to even go far. That X there, solution X, what is inside here? Is it not your silver triazonitrate 5? Your solution Y, what should be there? Is it not your HCl, dilute HCl? 1978 question 44. Look at what Jamb asks. An experimental test of the law of conservation of mass is illustrated in the diagram, right? In practice, the flux is weighed before and after the reaction between solution X and what Y. The question is, which of the following pairs of solutions would be unsuitable for the experiments? Which of the following pairs of solutions would be unsuitable for the experiments? Option A, we're given X is hydrochloric acid and then Y is your silver triazonitrate 5. Okay, and then you now say, sir, but X here is supposed to be silver triazonitrate 5. Whether they like, they should interchange the 2 of them. It does not matter. The reaction will still take place. Now, option B says your barium chloride should be X and then Y is dilute sulfuric acid. Sulfuric acid here is your tetraoxosulfate 6 acid. Option C says your HCl, that's your hydrochloric acid, and then your Y should be sodium hydroxide. And then option D says hydrochloric acid and sodium carbonate. Now, what is the correct answer to this question? Very, very fast. No time to waste time. X, yes, A says X is dilute hydrochloric acid and then Y is your silver nitrate. HCl and silver nitrate, can they react? Yes, it will precipitate silver chloride. So you can use it. Precipitation reaction and neutralization reactions can be used. Option B says your barium chloride and dilute sulfuric acid. Yes, a precipitation reaction will also be formed there. I'll show you. Option C says your HCl and your sodium hydroxide. HCl and sodium hydroxide, of course, that's neutralization reaction. Reaction between an acid and a base to produce salt and water is neutralization. You can also use it. Option D says your HCl, right, and your sodium carbonate. Sodium carbonate, of course, a gas will be formed there. What is the correct answer? Option D is the correct answer. Now, I'd like you to listen carefully as I explain all the options one after the other. Look at option A that we're given. Why is it that A cannot be the answer? Option A says hydrochloric acid and your silver triazonitrate 5. What is the reaction between the 2 of them? When hydrochloric acid reacts with your silver nitrate, what is it going to form? HCl and silver nitrate. What will it, but first, just assume that this HCl, of course, this is aqueous, right? And this is also aqueous. What will it give rise to? Your HCl, that's your solid, which will form the precipitate, and then HNO3, aqueous. So, anytime you see an arrow pointing downwards, it's telling you that it's precipitate. So this guy here is in precipitation reaction. And as a result of that, there will be precipitate of your work, your silver chloride, right? Yes, it will form, but no gas is formed. And because no gas is formed, the masses remains within the system. So we are going to option A, you can use it. Option B, very quickly, say barium chloride and dilute sulfuric acid. Sulfuric acid here is your H2SO4, tetraoxosulfuric acid. When barium chloride react with your sulfuric acid, what is it going to form? Of course, your barium chloride and your H2SO4. There will just be a exchange of radicals. Your BaSO4 will now be formed, and then your HCl be formed. Of course, your barium tetraoxosulfate 6, it's also a precipitate that is going to form. So the precipitate of your barium sulfate, which is your barium tetraoxosulfate 6, which is formed, means that you can use it to demonstrate the law of conservation of matter or mass, right? And no gas is produced. And because no gas is produced, the mass will remain within the system. We are able to go. Look at option C. Option C says hydrochloric acid and sodium hydroxide. If hydrochloric acid dilute HCl reacts with your sodium hydroxide, of course, what is going to form there? That's your what? Neutralization reaction between an acid and a base to come and form salt and water. You can use it. And why? Because it is neutralization reaction. And that neutralization reaction, we said precipitation reactions and neutralization reactions can be used to explain the law of conservation of mass or matter. Are you getting it now? And because of that, no gas is produced. How it is gaseous products now. You are now thinking that, okay, that gas can escape right ahead. Look at option D. Why we chose option D? Dilute HCl, whether it's dilute or not dilute, and sodium carbonate. Sodium carbonate is your sodium triacylcarbonate 4. When HCl and sodium triacylcarbonate 4 react, what is it going to form? It's going to give rise to sodium chloride, water, and carbon dioxide. CO2 is the carbon dioxide gas, and that will be given out as the gas, not precipitate. That gas is given up. Because of that gas, you know, that's why we always use cork in all this experiment. That gas has the ability or the potential to escape. And because the gas can escape, the production of CO2 gas now is not a threat. It can escape from the system. So the escape of the gas means that the mass will not remain constant. And because the mass will not remain constant, it will disobey the law of conservation of what mass. That's why it's the answer. I like you to understand this. Any gaseous product that is also formed is a threat. Are you getting it now? You cannot use your gaseous reactant. Don't even try that one. You cannot use your solid reactant. Any gaseous product that is also formed at the end of the day is a threat to the reaction. So get that very quickly with me. Don't forget very fast that I told you that there are 5 things I want you to know regarding the law of conservation of your mass or matter. Very quickly, what are the 5 things again? The 5 things include the following. Of course, I gave you the first one. Any precipitation reaction, you are good to go. Neutralization reaction, you are good to go as far as the law of conservation of mass or energy is concerned. And then number 2, I told you that reactions that involve a solid or gas, right, as the reactant cannot be used. Why? Why that you cannot use gas? Because it is difficult to weigh gaseous products, to weigh gaseous reactants. That's for reactants. And of course, when it comes to your solid being the reactant, you can't still use solid as reactant. Why? Because solid reactants are relatively slow, very, very slow. And please also note this very, very quickly. Attach this to your notes and understand this, that any gaseous product that is formed at the end of the day that is gaseous is a threat to the reaction. So it cannot also be used to explain the law of conservation of mass or matter. And of course, if you have a solid product being formed at the end of the day, that's nice one. It will show precipitation reaction, so we are going to go with that. And then number 3, very, very quickly, among the 5 things I want you to note, the reaction must take place in a closed vessel. You know, for example, like equilibrium reactions must take place in a closed vessel, right? Yes. The same thing for law of conservation of matter or law of conservation of mass, it must take place in a closed vessel where all the atoms present before the reactions are still present after the reaction. Else, total mass of the reactant will be equal to the total mass of the what product, just to validate the law of conservation of mass. And of course, I like you to also understand this number 4. Very important, that equations of chemical reactions must be balanced. So equations of chemical reaction must be balanced for them to conform to the law of conservation of mass. If the equations are not balanced, please, the law of conservation of mass cannot be used. Anything that makes the equation not to be balanced, law of conservation of mass, can it be used? It can never be used. Now look at your Jamb 1993 question 4. Look at what Jamb asked, a sweet question. And the question says a balanced chemical equation obeys the law of. What does it obey? Option A said it obeys the law of conservation of mass. B said it obeys the law of definite proportion. C said the law of multiple proportions. And then D says conservation of energy. That's why I told you from the onset that the law of conservation of energy is not the same thing as the law of conservation of mass or the law of conservation of matter. A balanced chemical equation will always obey the law of conservation of what? Mass, or the law of conservation of matter, and not the law of conservation of what? Energy. Are you getting it now? Making option A the correct answer. Please, again, don't forget that a balanced chemical equation reflects the law of conservation of mass or the law of conservation of matter, which states that the mass of the reactant must be equal to the mass of the product. Before and after the reaction, they must be equal. And of course, I'd like you to know that balancing the equations ensure that the number of atoms for each element is the same on both sides, whether for the reactant or for the product, thus conserving what? Mass. Right? Look at WAEC 2020 question 5. Look at the sweet question that WAEC asked. WAEC said a balanced chemical equation is based on the law of what? A balanced chemical equation. Which law is it based on? Is it the law of periodicity, law of constant composition? Is it the law of multiple proportion, or the law of conservation of mass? What is the answer? Law of conservation of mass, option 1. She makes it. These are the things that people fail in Jamb. You reason it now, reason it with me. Is it difficult? Is WAEC difficult? Is Jamb difficult? No. It just depends on who are your teachers. Are you understanding me now? Follow me very quickly. If you understand this very, very fast with me, I'd like you to know still on the 5 things about the law of conservation of mass or the law of conservation of matter that I'm giving to you. What are the 5 things very fast? Number 1, any precipitation reaction or neutralization reaction can be used to explain the law of conservation of mass or the law of conservation of what? Matter. And then number 2, I told you that reactions that involve a solid or gas as the reactants cannot be used. Why? They can't be used to demonstrate the law of conservation of mass because for the gases, it is difficult to what? To weigh your gas. That's number 1. Another thing about the solid aspect is that the solid reactants are relatively slow. So their reactions are very, very slow. And I told you that for the products, don't forget this very quickly, that products that will form gases, they are a threat to the reaction because they can escape. But products that will form solid, thumbs up, you can use it because they are trying to tell us that precipitation is taking place there. And if you understand that, number 3, I gave you that the reaction must take place in the closed vessel, right? Where all the reactants present before the reaction are still present after the reaction, else they are just obey the law of conservation of what? Mass, or the law of conservation of what? Matter. And then number 4, I told you that the equation of the chemical reactions must be balanced in order to obey the law of conservation of what? Mass. If you get this very quickly, 5 things. What is number 5? Stoichiometry is based on the law of conservation of mass. We're going to treat stoichiometry on its own as we are moving currently. You'll get to stoichiometry class very, very fast. Stoichiometry is based on the law of conservation of what? Mass. Does it make sense now? If you understand this very, very quickly, look at WAEC 2019 question 12. A sweet question. The question says stoichiometry is based on the law of what? Say the villain. Option A say multiple proportion. Option B say constant composition. C say conservation of energy. And D is conservation of mass. Listen, it cannot be conservation of energy. Never. It is conservation of mass or conservation of what? Matter. Making option what? Option D the correct answer to this question. Why is it so? Please, I've told you that stoichiometry is based on the law of conservation of what? Mass or law of conservation of matter. The quick question you want to ask yourself is, sir, what is stoichiometry? Right? As we move, you will learn stoichiometry. But please, stoichiometry is that relationship between the amount of reactants and products in a balanced chemical reaction. The relationship between the amount of products and reactants in a balanced chemical reaction, what is it called? Stoichiometry. If you want to understand this very quickly with me, this is everything from beginning to the end about your what? Your law of conservation of mass or the law of conservation of what? Matter. I gave you 3 powerful things, I mean 4 powerful things there. Number 1, I told you the guy that talked about the law, this law, right? Yes. I gave you the definition, I gave you their experimental analysis, and then 5 powerful things that are supposed to note. If you get this very quickly with me, I'll see you in lesson 2. You know about the 4 laws of stoichiometry. This is just one that we have treated. And all the past questions, as far as Jamb And Waec is concerned, we have looked at all of them. I'll see you in lesson 2. And in lesson 2, guess what? I'll take you around the law of definite proportion or the law of constant composition. See you in lesson 2. Bye-bye. Enjoy. Hope you've enjoyed this class. Guess what? To follow up for more classes, just download the LearnLift app, whether on Play Store or App Store, and then follow up your classes. You must do extremely well. I'll see you in class. Bye-bye.